Hello, welcome back. We're going to do another example with rational functions. Okay, let's go ahead and take y equals 5 times x minus 4 times x minus 2 divided by 3 times x plus 3 x minus 7. Okay, so what we're going to do here, we're going to look at a couple things. So let's first just talk about the end behavior. As x goes to plus or minus infinity, okay, the dominant terms are going to be 5x squared, okay, the leading terms on the numerator, divided by the leading terms on the denominator, which is 3x squared. Which here we do cancel this because this is just we're just talking about what's going on as x goes to infinity. Okay, and now we can go ahead, we can do a straightforward sign chart. So our roots or our zeros are at x equals 4, x equals 2, and our asymptotes, okay, the things that make the denominator equal to 0, are at x equals negative 3, x equals 7. All right, and now we can do a straightforward, we can just straightforward graph this thing, or sign chart first. So our sign chart, okay, it's going to have negative 3 comes first, then 2, then 4, then 7. And our pieces are going to be x minus 4, x minus 2, x plus 3, x minus 7. Okay. Now, at x minus 4, okay, at x minus 4, this is from the numerator, so we have a 0 there. Okay, so we're going to put a closed circle. X minus 2, that's also from the numerator, so a closed circle underneath the 2 across from the x minus 2. Now, underneath the negative 3 across from the x minus 3, I'm going to put an open circle because remember, negative 3 has to be thrown out of the domain. Okay, so I didn't write it, but I should have put the domain negative infinity to negative 3, together with negative 3 to 7, together with 7 to infinity, right? Because negative 3 and 7 were thrown out. Okay, and then finally at 7, we're going to have another open circle. All of these considered on their own, they slope up. Okay, so minus, 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 plus, plus, minus, minus, plus, 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 minus, plus, 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 minus, 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 plus. 4 minuses is going to give us plus. 3 minuses is minus, plus, minus, plus. Okay, now we can go ahead and draw our graph. Okay, I'm going to draw horizontal asymptote at 5/3. So that's going to be between 1 and 2. Now, you are allowed to cross horizontal asymptotes, all right? Horizontal asymptotes, you can cross them because they don't tell you, they're not restrictions, they're actually telling you what the function does when you go out towards the end, okay? -3, I have a vertical asymptote. At 2, I have a 0. At 4, I have a 0. And at 7, I have another asymptote. Okay, let me move this a little bit. Okay, ooh, that was. And now I can draw this graph, all right? It's positive. Excuse me. Excuse me. It's positive, and then it's gonna go up on top of that asymptote, okay? The reason being is there's no way it can go down. In order to cross the y-axis, it has to either cross at a 0 or it changes signs when you have an asymptote. So this has to go up, all right? Now, between -3 and 2, this is going to be negative. Up, between 2 and 4, it's going to be positive. And then after 4, it's going to be negative, going down towards that asymptote. Okay? So, you could actually find this point as well, which we will in a minute. And then after 7, it's positive. So it's going to be looking just like that. Okay? Now, what's the value of this point? Well, the x-coordinate is 0, and keep in mind this is not drawn to scale. And we're just going to plug in 0 here for all the x's. Okay, so what are we going to get? We're going to get 5 times -4 times -2, so that's going to be 5 times 8 is 40 over 3 times -7. So 3 times 3 is 9, times -7 is -63. So this is going to be 40 over -63. And what I wanted you to notice is that is indeed negative. It's underneath this x-axis, or underneath the y-axis. Or I'm sorry, the x-axis. Okay? All right. I'll see you all in the next video.